Lesson 25, graphing absolute functions. We'll be doing something called composite or piecework functions. That'll make sense in a minute. So off the bat here, though, let's just do some skills review to make sure that you guys have got this down. So go ahead and pause the video here in a second, and then I'll pop the answer up at you. So pause the video now. Okay, so there you go. For part B here, just make sure that you kind of read this right. This part was the part in absolute value bars, right? So you just did on whatever it was on the inside. So you ended up with 10 minus 16. So I had -6 in there. Take the absolute value, that's +6. This part was in the absolute values. That was -7. I just took the absolute value. That's just 7. This is just a subtraction symbol. I know it kind of looks like that. It might be like -3 in absolute values there. It might be confusing. But it's this part that's in the absolute values there. So then we just had -3 times the absolute value of -8 because that negative symbol wasn't in, well, didn't matter anyway because it was cubed, but, and then down here you can just see I took the absolute value of -8 was 8. So then we just had 6 plus 7 minus 24, which was 11, or -11. Okay, moving on. Composite functions or piecewise functions, same thing, can be used to define absolute value functions. So they're going to look something like this. Okay, so I'm going to come back to this part, though, in a bit when we get down to this express as a piecewise function. Let's graph it first, and then this will make a bit more sense. So we're just kind of doing things we've done before now. So part A says sketch the graph of y is equal to x minus 3, so no absolute value bars, right? So there's nothing on there. And then y is equal to the absolute value of 2x minus 3. So both of those in your calculator. So I'm going to open up a new graphing window. And I'm going to go 2x minus 3. Enter. And it's going to be a straight line looking something like that, right? So what I'm going to do right now is just sketch that. So that's what the original function without being an absolute value, that's what that would look like. As a little aside, what do you think this is going to look like now before we do it? Just kind of think about that. All right. So now in your calculator, we'll do the same thing, but I'll push tab to open up a new equation bar. And then we're going to go absolute value. So that's in that little book there. Absolute value. And then 2x minus 3. Enter. All right, you can see that we get that V shape again. It's that telling absolute value shape. Okay, so let's sketch that. So now this is going to look like this, right? So we've got like a Y type of a shape for both. Now, technically, we could figure out the X and the Y intercepts by graphing. We could, go menu and then all that stuff under analyze graph. But I'm going to show you guys how to do it without the calculator because you will need to show your work and you will need to be able to find these things without the calculator too. So let's go ahead and figure out what the x-intercept and y-intercepts are. And that's just of the red one now, the absolute value one, right? Okay, so looking at that, we want to figure out, okay, find the x-intercept. So go, so intercepts. X-intercept is going to be where y is equal to 0, right? Actually, you know what? Just for the sake of, just getting harder as we go, let's do y-intercept first. A little bit easier. So y-intercept. So the y-intercept is going to be, or when x is equal to 0, right? So we're looking for this. That's where our x value is 0 at that point. So let's just put in our equation then. So given this function, so y is equal to absolute value of 2x minus 3. Now I'm just saying, okay, when x is equal to 0. So let's just plop a 0 in place of that. So let's finish this and go y is equal to the absolute value of 2 times 0 minus 3. So then this is 0. So we just have y is equal to the absolute value of negative 3. And notice that what we had here, right? If it wasn't an absolute value, that would have been negative 3. But since we have the absolute value, now it's this one. So that's what the whole absolute value thing did, is it like flipped it upside down, right? Or right side up, however you want to think about it. So the absolute value here now is going to be positive 3. So you could say at this point right here, at our y-intercept, this is going to be 0, comma 3. All right, so we've got the y-intercept. We're good. X-intercept. That's going to be when y is equal to 0. Okay, so let's just start out with our equation again. So y is equal to the absolute value of 2x minus 3. So when y is 0, we got the absolute value of 2x minus 3. But hey, wait a minute. We were doing some of these ones where I said if we were solving for x in this case, we're going to have two situations, right? We're going to have like, one where it's 2x minus 3, and we're going to have another one when it's negative 2x minus 3, right? But the nice thing here is that these things are both equal to 0. So if this was equal to 0 and this was equal to 0, what you can see is that there's like a negative 1 out front there, right? If I divided both sides by negative 1, so 0 divided by negative 1, that's just 0. So they turn into the exact same thing. So there's only one solution for this anyway, so it's going to be a little bit easier. And that kind of brings me to my next point here, that we have a particular point there, right, where you can see where the blue one and the red one kind of go different ways. That's called an invariant point. Whoop, spelled that wrong. IA, invariant point. Okay. Yeah, so that's going to be the same for both. So maybe put in brackets here. Same for both. So that's why, if you look at what we're doing over here now, you end up with the same solution, because it doesn't matter, right? It's not that you're looking at one function and the other. That point's the same for the absolute value of y is equal to 2x minus 3, and also just y is equal to 2x minus 3. So stays the same. All right, so let's just keep going. So now that we know that, we can just solve for x like we normally would. We can even just drop those bars because they don't really matter, because we're looking for that invariant point. So we've got 0 is equal to 2x minus 3. We could say 3 is equal to 2x, and then 3 over 2 is equal to x. So that's where our invariant point is. So that's going to be at, if we go back to our graph here, so when x is 3 over 2 and y is at 0, that's the point where they flip, or where it starts going the other direction. Now, while we're looking at this too, I just want to, if you want to figure out where any other point on this graph is, because sometimes this confuses students, let's just say we wanted to figure out, like, what some point in right there was, right? Let's say when x was equal to 1. What you would do, well, let's say this one, because we're looking for the absolute value. So when x is equal to 1. So what you would do there is we just say, we start out with our function. So y is equal to the absolute value of 2x minus 3. And then just put in 1. So instead of x, we just go 2 times 1 minus 3. So then y would be equal to 2 minus 3 is the absolute value of negative 1. So y would be equal to just positive 1. So that's what that point right in there would be. 1 comma 1. X was 1, that was the thing we put in, and then we got y out of that. I just wanted to show you that, because if you're asked to sketch these things, it's not always just good enough to just plop it in your calculator. and just kind of sketch it out. It'll sometimes say give 3 points or 4 points or something on this graph. So you need to be able to do that as well. Figure out if given some value of x, what value of y would you get out? You could do that for any point along here, right? You could do it anywhere on here, anything. Okay. So that being said, I'm just going to erase this though, so we have a bit more room here. Next one says state the domain and range. Well, let's just kind of put A and stuff on these. So A, that was A. This was B. So now we're dealing with C. All right, so state the domain and range. So remember, domain was your x, right? Like the left and right. So you got to ask yourself, the only thing that could happen, like you can see that it looks like it goes forever to the left and goes forever to the right. The only way that it wouldn't is if you were dividing by 0. So it'd say, do we divide by 0? And the answer is no. Do we take the square root of a negative? And the answer is no. So there's no place that some value of x isn't going to work. So what we'd say then is that x is any real number. That's going to be like this for pretty much all of these. Okay. The other part of this, so that was domain. Range. Feels right over here. So range is going to be what is y allowed to be. We're looking at the red one, right? It's going to be everything above 0. It can be 0, but it's got to be everything above 0. It can't ever be a negative number. That's the whole point of an absolute value. So we're going to say y has to be greater than or equal to 0. All right, I hope you were able to write a little bit smaller than I was. So let's go D. So the last part, we're saying, okay, express as a piecewise function. So the way we do this is by writing out the original function, so f of x, or y, you could say that too. So y is equal to the absolute value of 2x minus 3. But we could also say f of x, just being a bit more detailed, that's the whole thing, that's all we're going to do here, is we're going to use these fancy brackets, and we're going to have two pieces. That's why it's called a piecewise function, or a composite function. Composite means made of pieces. That's if you have a composite stick, it's made of like hockey stick. I mean, it's made of different pieces. So what we're going to do is we're going to say where it's each kind of function. So really, we're splitting this thing into 2 points right at the invariant point. So we're going to say past this point, what kind of function were we using? To the left of that point, what kind of function were we using? So we're going to split it into pieces. So the first piece is going to be just positive 2x minus 3 when x, now I'm just going to say when are we using that function? When are we looking, like when is it this, the one on the right? Well, it's going to be that function for everywhere that x is going to be greater than, or you could say or equal to, doesn't really matter, greater than 3 over 2. That was that invariant point, right? That's where it reflects off the x-axis there. So that's the point where it changes. So it's going to be that function when x is greater than 3 over 2. Now, when it's less than 3 over 2, so everything to the left of that invariant point, we followed a different set of rules. We followed negative 2x minus 3. That's the function that we used when x was less than 3 over 2. And with that, like greater than or equal to or less than or equal to, since the invariant point is the same for both, it doesn't really matter which one you put that on, right? But just put it on one of them. Okay, so that's pretty much it. The last thing we just like to do is kind of like write this without that negative symbol out front in brackets. So we'd write this one more time as f of x is equal to, write the top the same, 2x minus 3 when x is greater than or equal to 3 over 2. And it's going to be 3 minus 2x. All I did was distribute that negative into both of those and then just wrote the 3 in front. Just kind of changing it up on you. And then when x is going to be less than 3 over 2. So all of that is what we meant when we said this. So that's kind of what we're doing with this piecewise function. It's just kind of splitting it up. It's just kind of giving you more information than that absolute value thing. Okay, let's. You guys are gonna be doing these for homework. I'm just gonna skip some, and that's what you're gonna do. I'm gonna go on and do some tougher ones, some ones with parabolas and stuff. Yeah, so let's do 3. Okay, so let's go ahead and do this one. So the first one says sketch the graph of that and then the absolute value of that. So I'm going to go, first one, we'll go negative x squared plus 2x plus 8, and then enter. So we got a parabola, right? Something like that. Let's make this a little bit bigger. Let's just make our window, let's make the y go up. So y max, let's set that to 12. Okay, so we got a good look at that now. So that's the blue one. Now let's take the absolute value. So I'm going to go back and go tab to open up a new equation bar. And then I'm going to push the book for the absolute value. And now we're going to do the same. So negative x squared plus 2x plus 8. Enter. And you can see we get that like Wu-Tang symbol again. You're probably too young to even know what that is. So yeah, the red one there. And again, it just flipped everything above. It made sure that everything that was below the graph, this blue part down here that you can still see, now that's above, right? That's above the graph now. So that's what we've got. So let's kind of sketch that out here. Okay, so there was my original function. Now, everywhere where it's below, so this stuff on that side and on that side, it's going to be above. So it's going to be the same thing, but it's going to be coming down like that. It's like a mirror image on that x-axis. It's like that. And then it would be the exact same up top. Okay, so something like that is our sketch, right? Okay, now... so remember, if I wanted to sketch this out without the use of a calculator, and let's say I wanted to figure out what, like, this point right here was, where x is equal to 1, you're just kind of making that up, you could just put a 1 in there. So put 1 in that, put 1 in that. Whatever you get out for y, that would be that point right there. So it would be 1 comma, whatever that function was equal to will go in for y. So just so you remember that. Okay, we are going to figure out the x and the y intercepts though. So let's figure out the y intercept first. So y intercept. So that's going to be where x is equal to 0. So let's write our function. So y is equal to the absolute value of negative x squared plus 2x plus 8. And then just throw a 0 in there. So you can see that y is going to be equal to negative 0. Well, I'll put it in. Plus 2 times 0 plus 8. This is all going to be equal to y is equal to 8. So that's that point right there. That's going to be at 0 comma 8. That's our y-intercept. Okay, let's figure out our x-intercept. That's going to be where y is equal to 0. So again, we don't need to, well, I'll write it. So we'd have 0 is equal to the absolute value of negative x squared plus 2x plus 8. I don't need to do like the positive version of that and then the negative version because they're going to be the same. Those are invariant points right there and right there. It's the same for both of those functions. So all I need to do is really just drop these absolute values and just solve. I should end up with two answers though, right? I've got two purple dots on this side. I should end up with two answers from this. So let's go 0 is equal to negative x squared plus 2x plus 8. Now, if I'm going to factor this, though, I really don't like that negative symbol out front of the x here. It just makes everything a lot more complicated. I'd have to, like, make sure that my numbers multiply to negative 8 and add to positive 2. It would just be hard to do. So what I'm going to do is I'm just going to you can think about this two ways. You can either move all this stuff over to the left-hand side, and then that would get rid of it, or you could divide everything by negative 1. Because if I divide everything by negative 1, all it does is swap all of my symbols. So divide by negative 1, divide by negative 1, and divide by negative 1. We'd have 0 is equal to x squared minus 2x minus 8. This would be the exact same thing as if I just moved everything over to the left too. So however you feel comfortable. So now I've got 0 is equal to, let's factor this, x and x, multiply to negative 8, add to negative 2, so be 4 and 2, and the 4 would be negative, that'd be positive. So this is going to happen when x is equal to negative 2 and when x is equal to positive 4. So those are our x-intercepts. It's going to be at negative 2, comma 0, and at positive 4, comma 0. Those are also going to be our invariant points, which are going to be important when we kind of write this out in piecewise functions. So, okay, now state the domain and the range. So remember, we're looking at the red part. So of the red part. So the domain, so what x can be equal to. So domain is going to be, well, we don't take any square roots of negatives or divide by any zeros, so x is just going to be any real number. Our range is going to be easy as well. Like all of these, it's an absolute function, so it needs to be above the x-axis. So y needs to be greater than or equal to 0. It can be 0. You can have the absolute value of 0 is still 0, so it can be 0. Okay, and then the last part here, D. Maybe I'll put numbers on these, or letters on these again. So that was part A, part B, part C, and then part D. So part D here, we need to figure out, so let's just grab our original function again. So I'll say f of x, I don't know, it's just, you see this more often as you get higher level math. F of x is going to be equal to the absolute value of negative x squared plus 2x plus 8. So a different way of writing that, though, is going to be f of x is equal to, and now we're going to split this up into pieces, and now we're going to have three pieces. I'm going to have the piece that's to the left of this invariant point, and then in the middle section, and then to the right of the last invariant point. So let's just kind of figure this out. So our original function was the blue function, right? So when everything was less than negative 2, so when the function was less than negative 2, we had to flip it upside down, right? We wanted the absolute value. That's the part that flipped, was that one. In order to flip it, all I did was I took negative of that original function. So just go negative and then put that whole function in there. So negative x squared plus 2x plus 8. So it's going to be flipped. You can think about that negative symbol up there as like just saying we flipped it. And we did, right? Because it was blue and then we flipped it upside down. So it's going to be that when x is going to be less than or equal to, sure, less than or equal to negative 2. Okay, hopefully you're following me. It's going to be our original function in this middle section between our invariant points there. that was the same as just the original function without being flipped. So it's going to be that, just normally just negative x squared plus 2x plus 8 when, now we have to figure out when what. So it's going to be when x is greater than negative 2 and when it's less than 4, right? That it's that middle section. So we're going to say, I just put an x like over here a little bit farther, and then say greater than, oh, that should have been negative 2, that last one, negative 2. And now I'd say it's going to be greater than negative 2, and it's got to be less than, less than 4. Okay, hopefully you're following me there. Now, let's, the last section there, that's going to be when we flip it again, right? This, when everything is greater than 4, we flipped it upside down. That's that part. So in order to flip it, what we did was we took the negative of it. So negative x squared plus 2x plus 8 when x is greater than or equal to 4. And then close your thing, and you're pretty much done, other than, we just don't really like it looking like that. So let's just write it all again, but with that written a little bit different. So we'd say f of x is equal to, make your fancy bracket, and then just distribute that negative into everything. So that would turn into just positive x squared minus 2x minus 8 when x is greater than or equal to negative 2. It's going to be just our normal function. I'm just doing a different color so you can recognize it. Plus 2x plus 8 when x is, when x is greater than negative 2 and when it's less than 4. And then it's going to be the same as the top one. We flipped it. When x is greater than or equal to 4. Okay, I know there seems like there's a lot going on there, but it's not too bad if you just think about like these points. It's all about these points. So what did we do before those points, and then what did we do after? So, okay, so I'm going to leave that there. I'm going to let you guys do the last one on your own. It's going to be similar to that number 3. Yeah, so that's going to be it for that one. Good luck with those 2 questions. So 2 and 4.